So if you're new to 3D printing, you're trying to get started, or you're getting started, it may be confusing how you build a 3D object, you slice it, you feed it to your printer, and then your printer firmware goes ahead and prints your thing. So we're going to try to go through that. Let's go through the 3D printing software toolchain. So for starters, you're going to need to make a three-dimensional file or go download one off of someplace like Thingiverse. There's lots and lots of files you can just download. But to create the file, this three-dimensional file is called an STL file. A lot of people use something like Blender or SketchUp to build the file. Okay, then you're going to import the file into something. What I like to use is Repetier host, and it's a package of software, and in it there are slicing engines. These are external programs, so you can just run them by themselves if you like. So what the slicing engine does is it takes this three-dimensional object and it slices it into little layers, maybe 0.2 millimeters, 0.3 millimeters thick, and then your 3D printer will print one layer, one of these layers at a time. After you slice, you can export another file, and it's called a G-code or machine code, and that's what your 3D printer really wants to see. So you can export this to an SD card, plug in your SD card and print, or if you're using something like Repetier host, you can manually control the printer, jog it around, heat it up, and you can hit print and it sends that file over the USB cable. So once this G-code hits the printer, you've got some electronics there. In this case, I'm using an Arduino board with a ramps shield on top of it. And there is firmware on that Arduino board. There are a bewildering amount of settings in here that you need to set for your printer to work properly. There's also a lot of settings you need to get right in your slicer for your print to really turn out well. And then also, when you're designing your file, there are things you need to keep in mind. It needs to be a printable file. If there's like some little pieces that are holding up a big object up in the air, well, that's not very printable. You might want to flip it over so the big object is flat on the bed, and then maybe some little pieces can stick up, because remember, we're building from the bottom up. Also, one thing people do is they use a really high power 3D modeling software like Blender and make the object so complex that the slicer can have trouble slicing the object. So I use SketchUp because it's a little simpler, and it's easier for me to get a precise dimensions on the object so that it prints exactly how I want to do it. So in this video, what I'm going to do is I'm going to go ahead and show you where to download a file. We're going to download Repetier host. We're going to download Marlin Firmware. We're going to get the firmware on the printer. We're going to get this installed, and then we're going to start doing calibration. So this is a very long process. As my Kossel guinea pig today, I'm going to use my Kossel Mini. I ran Repetier firmware on it for a long time. I kind of like the latest Marlin, so I'm going to go through about 8 hours of pain today and hopefully give a good demonstration. Before you start, there's a potentiometer on these stepper motors. Go ahead and set it to the middle. There's a flat piece on the top of this pot, meaning that it's pointed straight down. That's right in the middle. So crank them up later if you need more power for your stepper motors. A little tip, this filament is kind of translucent. I suggest you use a solid color for calibrating. I wasted a lot of time one time because the transparent filament can be a little harder to use. So the first thing to do is to start gathering some information about our printer. So we're going to start with the delta measurements. So the smooth rod offset between the center of your extrusion to the center of the hot end, the length of the diagonal rod, the delta effector offset, carriage offset, and the radius. So we're going to do these measurements here. This is about 213 smooth rod offset. So I'm going to go ahead and zero this all the way to the top. And I'm going to measure from the center of my hot end to the center of this. We also want to know our height from 0 to the bed. So I'm going to push this on the end stop. 240 millimeters. Then you need to know the number of teeth on the stepper. This is a 20 teeth pulley, and my stepper motors are the standard 1.8 degree stepper motors. On the Kossel XL I got some more precise stepper motors, which are 0.9 degree stepper motors. They're twice as many steps. And then the other thing we need to know, we're using these Palu stepper motors drivers, and I've got all these jumper pins installed underneath them, which means I'm going to use the maximum number of steps, which is 16. The printable radius variable, bring this down in the middle, and then let's measure how far we think this can print without hitting something. So we're going to go to about 90 millimeters. That's about as much as room as I can get here. Now I'm going to go ahead and real quick show you how to figure out how many steps per millimeter we need to put into our firmware. This is the Prusa printer's calculator. It's pretty cool. So you select the type of stepper motors. Like I said, I have 1.8 degree. So there's 200 steps per revolution. And also we have the Palu steppers with all of the little jumpers installed. We've got this 2 millimeter belt. It's a GT2 belt. And then how many teeth are on your pulley? So I'm going to do 20. Oops. Enter. And it says our default steps per millimeter is 80. So that's going to be our starting spot, and then we're going to go from there. Here is a cheat sheet. I'll have all this info up on my blog post. This is the stuff we wrote down, those basic settings, but I also documented the line number and the thing that you should check and maybe what to set it to. And these are all just initial settings, so we'll adjust them as we go. So software you need to get. You need to have the Arduino IDE. This is for loading the firmware and so that the USB drivers work. SketchUp Make, this is optional. You can get it if you want for creating files. NetFab Basic, it's really invaluable, honestly. And it's for repairing broken STL files, and we won't really get into that in this video. But if you get the latest NetFab, it's a paid product, but you can still download the old basic product. Repetier host, which we're going to install. Marlin Firmware. And we're going to go to Thingiverse and grab some calibration objects. Let's go ahead and fire up Repetier host for the first time. So let's go into our printer settings. You can see this is set up for a square printer. Remember this baud rate. We'll just set the same baud rate in the firmware when we download it. My printer's plugged in. I think it must be 14. Okay, Z-axis, I like this to be the same, 4800. This is fine. My heat bed, I like 60. I use PLA exclusively. And my default extruder temperature, 200, is great. Park position, we said that our printer height was about 240. So let's go ahead and just park it at somewhere up in the air. After we kill the job, I want it to go to park position. I don't have an SD card. This all looks good. I have one extruder. You can set min and max temperatures here. Diameter, I guess 0.4 is good. Printer shape. We're going to do a raw stock circular printer. And home position is 0, 0, and max. My printable radius is about 90. And for height, let's go ahead and make it, I said 240 with my ruler, but I'm going to make it a little bigger, and this will come up here in a little bit when we go ahead and try to get the exact height. So I'm going to do 250, and then we will adjust this down in a few minutes. Repetier host is good to go. I extracted the Marlin firmware onto my desktop. So there's Marlin. This is the firmware right here, and we're going to open this marlin.ino. But before we do, let's grab an example configuration. They were nice, and they gave us a Delta configuration for Kossel Mini. So we're just going to copy these two files, and it's just going to give us a starting spot, so we're not having to set every single thing from scratch. Okay. So let's do Marlin. Marlin firmware. Almost everything we want to adjust is in configuration.h. And I'll bring my little cheat sheet up over here. So we'll start with 125. Baud rate was what we thought. 132. You can see that we're doing the ramps board. If not, it says go into boards.h and find the board you want. Right here, this is a safety feature, so it won't extrude unless the hot end is hot. I like to disable this. You can totally enable it again. I'm not sure why they strongly recommend that you leave it enabled, but I really don't care. I'm gonna be calibrating the extruder, and it's a little inconvenient. If you want to leave this enabled, you'll need to send an M302, and how you do that is you pull up this guy, and once you're connected, you actually type in here M302 send, and it'll temporarily disable it for you. So this is already set up for us, but I'm just pointing out right here we're defining that this is a Delta printer, and if it's a Delta, then it's going to use these settings here. Let's go ahead and modify them. From our measurements we did earlier, my diagonal rods are 213, smooth rod offset 152, effector offset 31. I'm not sure why mine is so different. Carriage offset 27. So notice that it's generating a delta radius, and it's using the smooth rod offset right here, 152 minus the effector offset minus the carriage offset. So as we go to adjust this later on, we only need to modify one of these numbers, and we're actually going to just take this as a starting spot, and then we'll start adjusting this number up and down. I'll go over that later. So the printable radius was about 90. All right, let's go ahead and go over a couple other things real quick. In-stop configuration. So we're going to use the X, Y, and Z max plugs. If you plugged the in-stops into the other pins, you could use these others. I do want to pull up my in stops. I'm just going to take all these comments out. So all these pins will be pulling up, waiting for me to the switch to sync to ground. I don't care about that one. Okay. And then I just know from experience that I need to invert my particular in stops. So I'm going to go. How you would know is your in stops wouldn't work and you just need to try something. Okay, so this is a very important line. This tells us the steps per unit for every axis. So remember, we went to the calculator and we decided that we should probably do about 80 steps per millimeter. So that's good for X, Y, and Z. They all need to be the same. And then this is the extruder steps. So they're doing 760 multiplied by 1.1. So that's a fudge factor. I'm going to just take that out for now, and we'll actually just try to get the actual steps per millimeter when we calibrate the extruder. And then I don't have a Z-probe or auto bed leveling. These are the places where you could find those and turn them on or off. Let's just skip straight to the good stuff. So the manual Z home position. This is the height of my printer. We said it was 240 or 245, but I'm going to go ahead and leave this high. We will fine tune this number until the hot end is perfectly touching the bed. So and that'll be much easier once we get a firmware downloaded into this thing. So I'm going to go ahead and save this guy. I better select the right board, which is an Arduino Mega 2560, and my port is 14. Let's go ahead and upload, and this can take about 3 minutes, a couple minutes to upload. Alright, so here's a little tip. The EEPROM saves lots of settings for your printer, and it's used mostly for when you have an LCD screen. Since I've already been running Repetier firmware, I better blank out the EEPROM. You might not need to do this, but you just wait till the little LED turns on. It shows that it's done. Now I'm uploading this sketch again. It looks like it's connected. What I'm going to do is try jogging and access a little bit. So I'm going to try to move this up a millimeter. And it's working. I'm going to just jog it left and right. This is good. It's going that way. When I click up, all axes are going up. So if not, you can either turn over the pins of your motors. Also, if a motor is just buzzes and makes a weird noise, that means you need to rearrange some of the pins in the 4-pin plug. So take the top 2 and swap them, or the bottom 2 and swap them, and so forth until the motor moves properly. Then you can turn the whole plug, or you could reverse it in the software if you feel like. So I'm going to be brave. I'm going to click this home button, and it worked. So home brings it up and it hits the end stops, and then it gets ready to print. So let's do that again. You can also see that it shows I have a heat bed. It claims the temperature is 21, and my extruder, the temperature is 20. I'm just going to try these real quick and see if the temperature starts moving. If it starts moving up, that's a good sign. If not, then something may be wrong. So let's go ahead and turn the extruder on, see if it starts warming up. So these numbers are moving. This is great. This means that our thermistor for the bed and the thermistor for the extruder is working. Just kind of keep an eye on it. Don't accidentally leave these on when it's not working, otherwise it'll heat all the way up and damage something. I'm going to click on the fan button here. See, the fan starts running. You can also play with adjusting the speed. So once your motors are turning in the right direction, we need to calibrate and make sure that when we tell it to move down 100 millimeters, it actually moves down 100 millimeters. So what I'm going to do is I'm going to use my calipers. I'm going to get it down to where it's touching here. I'm going 10 at a time. Alright. I'm just going to get where I can measure something, so right here, 147.0. I'm going to go down 100 millimeters here. So, 2, 3. So that's 47.2. That is pretty much as good as you're going to get. It's 0.2 millimeters off. I think I'm going to live with that for now. The extruder, we're going to do a similar thing. We're going to tell it to extrude a known amount, like 50 or 100, and we're going to measure that exactly that amount of filament is consumed. Okay, so for this test, notice my filament, it's right up to here. It's not trying to hit the end. I don't want it to hit the end. I just want to be able to measure it here. So I'm going to do this, put some tape on here. And we're going to do the same type of thing. So we're starting at 120 exactly. Now I'm going to go move it 100 and measure it again. Alright, so this says 34, which isn't good. It only moved 80 when we asked it to move 100. So I'm going to show you real quick how to figure this out. In the firmware, we're saying 760, and that actually moved 80, which was not good. But we want it to be 100. So a ratio, you cross multiply and then divide. So 950. So I'm going to plug in that number and we'll try it again. So in our extruder section, we're going to do 950 here. And we're going to save it. Every time we want to reload the firmware, we need to disconnect the host. So disconnect, download, upload, sorry. It went 106. So I'm just going to tweak the number now. I'm going to tweak it back. So after tweaking it a few times and trying it again, I've settled for 890. It seems to be almost perfect. Now let's go ahead and get our home position set perfectly. What we're going to do is we're going to go ahead and click home. When you do, it goes all the way to the top, and then it's coming down a little bit. We're going to manually jog it down. And we're going to stop a little bit above the bed. Now I'm going to take a post-it note, stick it under here, and just move it down 1 millimeter until it looks close. So there's 1 millimeter. Alright, it's not quite touching. Now I'm going to do 1/10 of a millimeter. And I'm just going to wait until it's dragging on this paper. There, it's dragging pretty good actually. So if I pull the paper out, it's pretty much touching the bed. So I'm going to pick that number. So remember, we started at 250 minus 4.8. We get 145.2. 245.2. So we're going to do 245.2 here in the printer settings. Hit OK. I'm going to close that. 245.2 here. Go ahead and upload. We're going to do this again. We're going to go ahead and home. I've also noticed that this thing homes really fast, so it's actually like slamming into there. So I'm going to cut that in half. So now this thing's just about perfect. You want to home fairly slow so it's a little more accurate on the in switches there. Now when we go ahead and jog down, there's 40.4 millimeters, 0.3, 0.2, 0.1, and then I'm touching the bed and it's dragging pretty hard. This is perfect. Alright, I got to calibrate two more things and we're done. So when you home and you come down here within, let's just keep it about a millimeter off of the surface. What you're going to do is visually look at that and then jog it from side to side. So we're going to go and observe to see if it's flat. If our printer radius is off, the head could move in a convex or concave shape. So we've got to adjust that. And then once we get that perfect, we need to adjust how level the bed is. And to level the bed, you simply just loosen up an in-stop and move it. So let's say the bed was going this way. Well, you would adjust this in-stop down until the bed is flat. So it's a little repetitive process. Okay, so I'm going to go to the side a little bit. Notice that I'm fixing to crash into the bed because it's coming closer. Now it's almost crashing into the bed again. So it doesn't look like it's a level problem. It looks like it's a printer radius problem. So that definitely made it worse. So I'm going to go the other way. So I increased the radius by about 13 and it's almost perfect. I'm sure it's not quite, but anyway, it certainly moves a lot better. Looks like I may have gone a little bit too far. Okay, so I'm finally pretty happy. This is 1/10 above the print surface. If I go down 1/10, it drags pretty hard. Now I'm going to go over, go down 1/10, and it's dragging about the same. All four directions. Dragging, I go up 1/10, it's not. It's kind of dragging right there. Go down. It's not really dragging. So I need to adjust this instop up about 1/10 of a millimeter, which is pretty challenging. You just loosen the screw up. Just move it a very little bit. Once you do that, you may have to adjust all your Z height again. But it's an iterative process to get it tuned in to where you want it. I actually think that's close enough for now. I'm going to just try to print something. So let's get in these calibration files. Let's do this thin wall. I'm going to drag it in there. All right. So we're going to slice it. Pick your slicing engine. Let's do Cura. Slicer works too. We need to configure this guy. We can probably leave the speeds at default. For filament, we've got 1.75 filament. I want my temperature to be 200, bed at 60, and save. Let's go back over here. So default quality, I'm going to go ahead and add another one. There's really no reason to start with 0.2 millimeter. Let's do 0.3. Okay, so my layer height is going to be 0.3. First layer height is 0.3. Fast, I'm going to make this a little faster. My travel speed doesn't need to be that fast. You can run into stuff if it's trying to go that fast. So that looks good. We're going to save that. We're going to slice it. And I think that Cura hates that thin wall thing. Let's see. Is this thing? Yeah, there's no preview here. I don't think that was going to work. So let's go ahead and try Slicer for this particular object. It's good to set up both of these. Sometimes an object won't slice with one, so go ahead and slice it with a different one. This will give us a chance to configure Slicer. I actually accidentally set this up off camera, but it's almost default. So I'm going to do 0.3 for layer height. Speed, everything looks pretty good for speed. I picked my filament size, and then on my extruder I told it the actual diameter of the nozzle, which is 0.4. Save. We'll go over here and slice it with Slicer. Okay, this is good. The print preview shows us that it's sliced properly. Should take 2 minutes. There's 33 layers. It's going to be really fast apparently. So what I like to do, let me make sure my fans are all on my printer. We're going to go ahead and manually run these temperatures up. I like to do that anyway. It's not strictly necessary. You can just hit print. But I'm going to go ahead and hit print. And we're going to wait for it here. Once the temperatures reach their proper levels, it'll start printing. If the graphic card on your computer can handle it, it'll actually visually show you the printing there. On laptops with poor graphics cards, it'll disable that visualization to preserve the print quality. So that looks pretty gorgeous to me. Not too bad. Then, as with most of these files, there are specific dimensions, so you can get out your calipers and see, like this one's supposed to be about 20 millimeters. But the filament itself has a certain width too, so that's going to take up about, yeah, so it looks a little bigger than it's supposed to be. Anyway, I think I've had enough fun for one day. I hope this helps you guys out and demystifies 3D printing. Thanks for watching. Like and subscribe.